Swayam Prabha. Digital India. Educated India.
In essence, these middle boxes could be employed to provide various services. For example, the traditional in-network services like the carrier-grade NAT, wherein we could be using these devices to translate the private network address to a public IP and public to the private, vice versa, so that we are able to facilitate connecting many of the users within a LAN to the network services using a single public IP address. Or consider a load balancer, which would be used to ensure that any incoming traffic for the dedicated services that would be running on our network is balanced with respect to the load for each of the different instances of the network servers that we could be running. And likewise, they could also be used to facilitate and provide the security services. For example, the firewalls, the most commonly employed middle boxes. These could, even the types of firewalls could range from being the simple stateless firewalls to the rule-based firewalls that can operate at layer 3, layer 4, or even up to the application layer firewalls or the next generation firewalls that we think of. And when we speak of other kinds of security devices, we typically think of the intrusion detections or intrusion prevention systems. Imagine the network intrusion prevention and detection systems as the middle boxes that could be deployed within the network. And again, we could also have deep packet classifiers where whenever we suspect of any malicious content and want to analyze packet by packet the contents, we could have the DPI engines that could be running within the network. And also to safeguard from the DDoS attacks that typically happen on the services that are being run on an enterprise, campus, or data center networks, we would want to build specific purpose-built middle network appliances like DDoS protection and so on. Besides, they could also be used to provide specific value-added services for the services that are being hosted within a network. For example, as an enterprise network or campus networks, we could have WAN accelerators that could either be providing the cache of the contents that we typically access. We could also have them compress and decompress the packets before transmission. And if we think of telecommunication or ISP networks, we could even have the add insertion modules within there, including the data centers, where when you try to search for Google, the Google data center would have add insertion devices which would insert the ads that you would see on your pages. We could also have, when we consider the telecommunication networks, we could have these SBCs or the session border controls that typically manage and handle the VoIP specific services over the telecom networks. So likewise, we can see that these middle boxes, although like when we said a single firewall, they may come in different types and shapes. So the amounts of services, kind of service that you want, all would require that these are specific purpose-built hardware for specific network function. And when we look at all of this, the takeaway here is that there is a significant usage of the middle boxes. That is, it highlights the dominance of the middle boxes, and it's not that these are an inessential devices that came in. These are also playing a very significant role in different networks, be it the campus or the enterprise networks, or be it the data centers or the telecommunication or internet service provider networks. These middle boxes play a crucial role in each of them. So another important aspect when we tie with these middle boxes is often that it is not just one middle box that is used in isolation. And what we eventually see is that these middle boxes are often used in conjunction with other kinds of middle boxes. And there is a dependence of how these middle boxes are used, set up, and deployed. And that's what we call as the service-based network functions that we are going to be using. And the reason being that we use these middle boxes to facilitate a subset of the network services that we want, Or when we think of campus or enterprise networks, we want to enforce certain policies for different kinds of traffic. And when we say these policies need to be applied, we are talking about what kind of middle boxes need to be employed for enforcing these kinds of policies. So for example, in this diagram, if we look at two different kinds of traffics, very simple traffic that is originating from within the network, or it could be the traffic that is coming outside of the network from WAN. Or it could be that we have within the campus, we have multiple of the departments that could be using, so traffic that is originating from students, and it could be the traffic that's coming from the faculty and staff. So there are different means of the ways we can classify the traffic, and for each of these kinds of traffics, we may have different policies to enforce. And if we consider this example here, what we are showing is a blue kind of a traffic and a green kind of a traffic. And consider the green is the one that's coming from external to the campus network, which means maybe it's going to use the services that are being put within the network through use of the VPN devices. And VPNs are another kinds of most prominently used middle boxes. So when the traffic comes in green, what we are trying to show here is any traffic that's coming through the firewall into the campus network could connect through the VPN and then go through the load balancers and layer 7 optimizers like application filters for www HTTP contents that we may be using and ensure that the services are provided in the best way. And likewise, for the blue kind of a traffic, we may want to inspect for any malicious content through the IDS and IPS services and then connect them through the forwarding proxy and connect them with the application filters all the way to the necessary services. So this shows that when we define these middle boxes, we are also defining how the traffic needs to be routed from one device to the other. And this firewall itself may be trying to classify the blue versus the green kind of a traffic and route them to different instances of middle boxes. Also, as the traffic gets forwarded, we see that different middle boxes take the decisions on their own, like IDS or IPS may even drop the packets. The firewalls could drop the packets. The load balancers would choose what would be the end host where you would want to, which of the end servers that you would really want to send the packet, send the traffic towards. So all of these middle boxes are going to take their decisions on their own and also say where to route or impact the way the traffic would be forwarded from one instance of a network appliance to the next. And this is where we see the complexity in terms of how these have to be set up. And this was analyzed very thoroughly, and the kinds of middle boxes that were there in the early 2000s were studied and put up in the RFC 3234, which basically classified the networking elements that existed in terms of the network appliances and provided the means to understand the kinds of middle boxes and what are the challenges that each would bring along. And the core of this document is about the cataloging of the number of types of middle boxes. And then when we speak of these middle boxes and when we said they have different kinds of services they can provide, but then the question becomes how do we classify them and what's the means to build the classification. And this document, this study, put forth that there are multiple facets through which we can classify, and it could be a multidimensional taxonomy that we may be thinking of. But we need to consider specific characteristics in terms of how the middle boxes can be classified. And this could be as simple as saying that based on what layer of protocol or layer of the network stack that these devices would operate. For instance, consider a protocol layer at which these middle boxes would operate. Could be one of the means to classify these devices. That means whether the middle box acts at an IP layer or does it act as at a TCP layer or does it act at a layer 7 or the HTTP layer could be one of the means to classify the devices. For example, the firewalls, we could have a layer 3 firewall to layer 7 firewalls. And likewise, when we have the load balancers, we could have the basic layer 3 load balancers or layer 4 load balancers. So the variety, these classifications for a same middle box can even be done for at a different protocol level. And another way to consider this classification could be based on like how these services are being provided, whether is the middle box function an explicit design for a protocol, like when we consider SMTP replays, which are meant for specific SMTP functionality only, or is it an add-on that is being foreseen for trying to circumvent certain networking aspects, for example, the NAT device, because we are trying to add these NATs as translators to circumvent the issue of the public and private IPs. So we can call these as explicit versus implicit kind of networking devices that we can have. It could also be on the basis of like the way these devices could carry the state. They could be stateless to begin with, the most simple, where you just have the rules in the stateless firewalls where they would just allow or deny. Or you could have the firewalls themselves build the state with respect to the traffic they are serving. And if you take the load balancers, they are maintaining the state for each of the incoming flow to which server the map for that flow is being set. So these kind of things become like a state. And why state is very crucial is if the services break, that is if the middle box breaks, can it recover on its own and facilitate that end-to-end connection remains intact, or does it have a repercussion in breaking the end-to-end connection entirely? Like if we had a NAT and the NAT rules are being taken off, or a NAT device restarts and there is no state anymore for the ongoing connection, now we need these connections to be rebuilt. And this cannot happen until and unless the informations are brought back into the NAT device through the flows that originate again. And that's where like the state can be an aspect to classify these middle boxes. And we call this as a soft state versus hard state. That is, if the boxes lose the information and still the sessions can continue, and this is typically true in the case of value-added services that are being provided, while like the cases where the state is implicit and necessary for the service to happen, like in the case of a NAT and others, we call that as a hard state, wherein if that fails, the connection fails. And the classifications can be in many more diverse ways. I think this document talks a whole lot about the way the soft states, hard states, the way the issues with respect to how the optimizations are being provided, whether they are what kind of processing the devices are doing, whether they are manipulating the traffic at layer 3, layer 4, layer 7, what are the changes that they are adding, what is the side effect with respect to any of the devices. All of this has been discussed in this RFC 3234, and understanding of this is a must to understand why are middle boxes a real benefit, or to see the other side of what are the challenges that they bring. So to summarize this in the context, the rise of middle boxes has given both the positive edge as well as a negative impact. And if we think of end-to-end principle, and especially when I spoke about the hard state, they in fact break the end-to-end principle. And nonetheless, it does not nullify the desirable properties of the middle boxes, because we need these NAT devices without which we couldn't have been able to successfully support the lot of users to connect to the network. Right? However, the future application protocols that we would want to define have to recognize how these middle boxes operate, what are the means or constraints that they bring along. And that's where it becomes essential to question how we want to build, or what aspects we want to build in middle boxes. And having carried these thoughts, we said the number of middle boxes and the middle boxes by themselves have become inevitable in the networks. And when we look into these middle boxes, we often refer to them as just the intermediaries. That is, their existence is always almost transparent. In essence, neither of the two communicating parties or the hosts would know of their presence. And this model is often called as the bump in the wire model. Like when you are driving on a highway and you have a bump, you slow down and then again pick up your speed, right? It's the same what happens with respect to the packets that are communicating between the two end hosts. And when the packets are destined from one host to the other, the routers and switches would only process in terms of where to forward, where to send the packet next. But these middle boxes acts as the bump, wherein you now have to provide additional services or additional processing on these packets. For example, you want to build a NAT, then you are trying to modify and translate the packet headers. Likewise, with respect to load balancers, you are looking up the state and trying to match which of the servers that you would want to send. So you're even changing the steering of the packet to altogether a different server. And this processing comes with a cost, and that's one what it really impacts the packets that are flowing between the two ends is the added delay or additional latency in reaching the two end hosts. And that's why the model of this middle boxes that are being interspersed, they always add to the latency. And that's why they are referred to as a bump in the wire model. And again, when we are having this kind of a communication that is without the knowledge of either of the parties, you are not sure what kind of processings they are doing, or is it tangibly providing the same data as what you would expect on the other end. There is no guarantee on this. But we trust in the devices to be providing the key services to enable the kind of functionalities, but it also means that these are in a way a threat to this, ensuring that integrity, confidentiality, and reliability of the data that we may be transacting. And these middle boxes come in variety of uses like NATs, firewalls, tunnel endpoints, traffic shapers, and application accelerators, and so on. And this is where we see the two phases. One, they are a practical necessity in terms of their deployment is necessary to solve the networking problems, and their needs are not likely to go away by just putting the functionalities at the end hosts. Hence, they become quintessential devices to be facilitated within a network, and we can't get rid of them. Second, by principle, they are breaking the foundations of how we envisioned the internet, because they are violating the layering principle, they are violating the end-to-end principle, making the networks to carry state besides just carrying the information. And once we have anything to do with state, we know that failure in such a things could add to much harder repercussions. And the devices, when they are more, they may have bugs in themselves. They may be tough, having issues with configuring these kind of devices as well. So in a way, they are also an abomination in a sense that its minimal use is better, but the reliance on them could create troubles for us. But because they are also a practical necessity, we have to live with them. That means we need to think of the ways where we can work with these middle boxes in a better way and simpler, and make the workings simple. And this is where we need to now look at what are the key pain points that these middle boxes bring along and how we can really try to address them. So again, if we revisit the same networks that we thought of earlier and now see that we have just one simple middle box that is being deployed, the first question that these middle boxes bring as a pain point is how do we manage these devices? Because when we deploy the routers and the switches, we manage them in a specific way. Likewise, when we deploy these kind of middle boxes, which are again like purpose built by a specific vendor, specific OEM, and the manuals for these devices to handle, configure could be altogether completely different. So we need the skills and expertise to deal with these kinds of specialized devices, and that's where management becomes a pain point. Next, when we scale these different devices, the management problem is going to scale again, because the firewalls could be provided by a specific OEM. Their specs would be completely different than the proxy devices, which could be provided by some other vendor. The load balancer network appliance could be from many other vendors. And managing with each of these requires specific skills of having to build. And that means we cannot leverage the same skill of, okay, I'm well versed with the interfacing with the firewall, I can use the same knowledge to interface with the load balancer. That won't work. So we need different kinds of skills to deal with these kind of specialized devices. And that's where each of these devices present a narrow set of interfaces where one needs to get the expertise with. And this management in terms of how do we configure these devices, how do we set up these devices, and how do we interface with these devices and ensure that things operate in normal way in a network. So we would now be asking for specialized skill set to manage these specialized devices. And second, like I said, these are all like a bump in the wire. The more we add these devices, the more we are going to end up paying the price in terms of the latency. And hence, they could also create operational hazard in terms of when the processings happen. And if they silently discard or drop the packets, we would have to then know where the things went wrong or what are the consequences thereof. So all of these aspects make middle boxes the real pain points in deploying. And first of the issue is that these middle boxes, like we said, they are purpose-built ASICs which are going to be deployed. That means they are going to increase the capital expense necessary to deploy these devices upfront. And you'd see many of these middle boxes cost tens of thousands to hundreds of thousands of dollars. And being able to making them afford and deploy them becomes a challenge. And that's where the increase in capital expense would be enormous. And second, once we deploy these, we need to operate with them continuously. And that means they are going to add also to the operational expenses to deal with these kind of devices. And once we deploy them, another major problem is, like we said, the routes for these devices, how they are connected, which middle box would serve the traffic at which endpoint, and where is the traffic, the exit traffic going to, or what middle box it needs to go. And if we have to scale up these services or add more, we have to reconfigure the entire networks. So this greatly limits the flexibility of adding or removing the middle boxes once they are deployed. If I want to take out now the firewall, I have to rewire the entire thing to say now the data that is flowing from one middle box to the other are set up appropriately. And if I want to add another new middle box, it's going to be the same kind of a problem. And that's where they greatly limit the extensibility and flexibility, making it a lot more problem in terms of even the physical operations. To address more on the management complexities, the survey that was conducted earlier also tried to study on the aspects of how the middle boxes affect the failures and what are the complexities involved in managing of the middle boxes. And the survey of various network operators showed that when we speak of the different middle boxes, firewalls prominently add to a lot of misconfiguration issues. Especially that means it is complex to manage or handle with the firewalls, and getting the expertise to configure them properly is an important aspect, and that's a challenge. And likewise, the proxy devices, how are you setting up and configuring these proxies, was seen to be a major aspect which was resulting in the failures. And like 67% for firewalls to almost 63% for proxies to 54% for the IDS, where the network operators voted saying that these were more prone or susceptible for misconfigurations. And that means the lack of expertise in handling these devices. And likewise, like how these devices, when they become overload or lead to the potential problems in network traffic. Like firewalls, again, seem to be the prominent cases when they are stateful firewalls. resulting in a lot of processing overheads, a lot of delays, resulting in the failures. So it becomes interesting to see that these middle boxes, although like it enumerates a few of them, there can be a lot of repercussions in terms of the downtimes that we may see because of misconfigurations, or in fact adding to a lot of adverse effects in the network, creating a lot of processing and overheads, consuming a lot of power, and so on, could be the issues that these middle boxes bring along. So the survey tried to further look at, like, if I have a network with a number of middle boxes, what is the resource personnel that we may need to ensure that the middle boxes can be configured and set up. And what this shows was that a network with around 2000 of the middle boxes would require around 500 or more operators to manage them. So the x-axis is showing the number of middle boxes that you would want you have in your network, and for the corresponding number of middle boxes, what are the specific resource personnel with specific expertise that you are hiring to manage those network appliances. And you can see that for around 1000 or so, 2000 of the network middle boxes, you are going to spend on 500 or more operators to manage them. That means it's going to be a huge operational expenses that these middle boxes bring along. And to take out, these middle boxes are critical for security, performance, compliance, or policies aspects that you would want to enforce, but are really expensive, complex, and difficult to manage. And this is where we need to see how we can address these specific challenges with the middle boxes. And these were primarily the key motivation aspects in trying to see that we want to operate with the middle boxes, but alleviate these pain points. And to sum up the pain points, these middle boxes are, in essence, they make the carrier networks more complex, and you would need specialized expertise to manage these individual devices, because each is a dedicated hardware and a software, and the skills for operating with one hardware and software would be drastically different from operating with the other devices. And moreover, when we deploy them in large numbers, they make the networks essentially very complex, making them very difficult to manage or very difficult to even alter the topology of the network services that we would want to add. So if we want to bring in new services on table, we have to run and work through the current model of how the middle boxes are being set up, where to jig up a new middle box, what kind of integration plan needs to be done. All of this has to be well planned. And again, these kind of middle boxes, they also account for space and power in the network infrastructure. So the space and capacity planning needs to be done to ensure that we can accommodate these middle boxes. And besides operations being expensive, and we have seen, like when we see the firewalls, they started with the simple stateless to the enhancements and improvements, and these middle boxes have seen drastic improvements and enhancements over the kind of devices. And that means when you spend hundreds to thousands of dollars in deploying these devices, you may want to keep on upgrading and change them as you go. That means they may rapidly reach the end of the life, and moving out or moving in with the new devices could also add to a lot of, again, the capital expenses coming up. And even the most other significant aspect to a worrying aspect is we have a solution that we need today, but we cannot have it until it is being shipped and provided from the specific vendors. That means we have a procure stage, and then we design the things and we see, okay, whether they fit or we need additional things. And once we say there are additional requirements, these need to be designed, deployed by third parties or the OEMs, and then we need to again integrate and deploy them back in our networks. So the cycle of procure, design, and integrate, deploy could span years, which would also make it more difficult to address the immediate or pressing functions that we would want to serve with the middle boxes. So overall, these middle boxes end up providing very high capital and operational expenses, and deployment of them and management could be time consuming, and as we saw, misconfigurations could be the casual occurrences and hence leading to lots of errors. And they could also be subject to the physical and overload failures that would otherwise also impact the way the network services would be facilitated. And hence, having these traditional networks model where we think of these network appliances as dedicated hardware and software which are being run as one physical entity per node, like one hardware, one functionality, could all mean that there is a lot to pay for, and hence we need to simplify these aspects. And now if we think of these problems, and if we jump back and see how the things were when it was with respect to the clusters or the great networks or the cloud infrastructures themselves, in the essence that we had to deal with a lot more physical devices, physical servers, bring up the network, storage, compute all of those devices together and manage them. And how it was done in the IT or the cloud services was essentially with the use of off-the-shelf commodity hardware. And more prominently, the way we would want to scale or set up the things was through the means of virtualization. So when we virtualized these off-the-shelf commodity hardwares, we built off-the-shelf commodity software or virtualized instances, wherein I could consolidate many of the servers that would otherwise require a dedicated hardware now to be run on a single hardware. And that was the beauty of the virtual machines that we got. So now if we retrospect and see whether this would fit for these network appliances that we just discussed, and in what way can this really aid to break the challenges that we just saw. And we can see that with the use of the commercial off-the-shelf or the COTS or the commodity IT platforms, we could basically use a single hardware to facilitate multiple of the network appliances, the functionalities of different network appliances. And this would also mean that now we would not have to spend a lot more on getting these middle boxes, but it would make these middle boxes very, very cheap or inexpensive. And it would also allow us to host a large number of these devices on a single commodity hardware. So I can mix and match different kinds of network appliances that can be run on the commodity hardware. Second, if we, rather than just limiting ourselves to the commodity hardware and add the virtualization, augment that with the virtualization, this allows us to completely abstract the hardware and hide any of the unnecessary complexities that we have to deal with in managing the hardware. The use of virtual machines and virtual networks put together. This would now enable us the much desired elasticity in terms of we can bring on multiple instances of the same virtual machine as and how we need, and we can scale to the network demands. And virtual machines allow us to automate. At one point, we can sit and start spawning these virtual machines rather than going and setting up the hardware, booting them up, wiring them. All of these hazards could be taken off. And hence, the use of virtualization, we can see that it can really enable us a lot more flexible means to manage and set up these devices. And third, when we make these network appliances as software applications that are going to be run on these virtual machines, now we can again bring the abstractions in terms of how the interfaces could be designed and aspects of how to manage these devices, which can again be unified in one way. That way we can eliminate the overheads of having specific resource personnel to manage these devices. Nonetheless, we may not be able to get rid of all the complexities thereof because we still need the expertise who could understand what this software appliance would do, but we could provide better abstractions like an intent-based configurations that we spoke earlier. He doesn't have to understand the nitty-gritties of the softwares, but provide the intents which can then be translated to the device-specific characteristics that they need or software-specific parameters that can be broken down and set up. Thus, these observations that we make here make us rethink of using the hardwares and try to see whether we can softwareize these dedicated appliances and provide software-defined functionalities first, which could be run on the commodity or the shared hardware architecture. What this would mean is now a single hardware could be facilitating multiple roles or multiple network appliances all run on one hardware. So management-wise, it becomes a lot more easier. Infrastructure, capacity planning, again, simplified. And when we have these softwares and build the right abstractions, also the operational costs and management costs could be contained to a greater extent. And this is exactly what the network function virtualization deals with. So instead of these middle boxes, which are specific or a proprietary hardware software combinations, and each middle box being one physical on a node, which was seen to be very expensive because they are purpose-built hardwares, which also have these issues with deployment because you have to statically set them up, wire them up, plumb the connections, making them hard to manage or scale, and having them in hardware makes it difficult to customize or add new features, making them highly inflexible. Two, what we speak of network function virtualization is to run these hardwares as software entities, where you are going to run the router, CDN, any of the network appliances as a virtual router, virtual CDN, virtual firewall, and likewise. And these are all going to be run on the commodity hardware, which is the shared hardware infrastructure where you have the compute servers, storage servers, network connections being made for these servers, all of these as a commodity devices now, which are going to run these network appliances all in one. So you have made them go inexpensive because you are running on a standard off-the-shelf hardware or the server machines, x86 machines that we speak of. And now because we can bring these appliances at will as like trying to spawn a new process or spawn a new virtual machine that is going to run on this hardware, it makes it a very dynamic infrastructure where we can easily scale up or scale down or scale out the services as we need. And because these are softwareized instances, it becomes a lot more easier to manage and modify these devices, or even to bring innovation readily onto table because we can write the codes. We have the power to write the code, power to create new kinds of these virtual middle boxes without having to depend on the OEMs or any proprietary vendors to provide us these functionalities. And that's where network function virtualization tried to shape what we see as a means for network softwareization, helping immensely the network operators in building and managing these networks. So to sum up, what we really see is that this NFV brings in a means to run these network functions as software-based devices on a fast standard hardwares for the x86 server machines to think of, making the entire implementation of the network appliances as a white box model, wherein we have the control over both the software and hardware and enable any of these functionalities like routers, firewalls, broadband accesses, and so on. And second, because these are now the function modules that we are thinking of, we have full control over what the data plane has to be and the control plane has to be for these models. Like if we think of a DHCP, now we can build a DHCP software, run it on our Linux machines, NAT, which we could run on our x86 servers, the rate limiters that we would want to deploy or employ. All of these can be thought of as very simple function modules, and we get to have control and data plane operations done quite easily. And third, because these are virtual machine implementations, or rather we now call these network appliances as virtual appliances, we leverage all the advantages that come along with the virtualization or the virtual machines. That is very easy to provision the resources, and it can be automated. In fact, sitting at one point, we can spawn multiple of these virtual machines. We can scale on demand rather than waiting for a new hardware to be procured, set it up. We can have a very timely scalability. We can even move from one server to the other. When we want to manage, or if some device is going down, we can migrate the virtual machine from one hardware to the other. This greatly adds to the mobility and enables us to have uptime a lot more. And overall, because these are virtual machines, we don't have to spend anything on buying the hardware. It significantly lowers the capital expenses. And having softwareized these devices, it gives us a new means to say how we can standardize the APIs, like what way we can build the abstractions so that we can deal with the different middle boxes in a simple, coherent manner. And this is where the formation of the new industry specifications group in HC happened around November 2012, which has been laying the foundations of how middle box abstractions can be brought, what are the frameworks for deploying these middle box, what should be the architecture for building the network from NFVs or virtualized network functions, that we will start to understand in the next part.